Tēnā koutou katoa. My name is Harrison Parks. Today I'm going to be talking to you about swim programming. Swim programming is the act of creating a set of instructions for a swimmer or a squad of swimmers to swim in the pool. These instructions specify the stroke, the distance and the intensity at which the swimmer should swim. My project, swimDSL, supervised by Christoph Bartnik, is to create a language which both a human can read and write and a computer can easily process and understand. Now, you may have the question, why? Why would we standardize swimming instructions? Why does a computer need to understand that? Well, as it turns out, there are some interesting applications that we can create from such a standard. So, the first is that it creates a means of unambiguously communicating a swim program between swimmers and coaches. Perhaps more interestingly is that it can allow for the analysis of a large amount of programs by a computer. And so you can imagine an Olympic swimming coach, would want to know how their swimmer is improving over time. And so if the computer could know all of the strokes and the distances that they have swum in all of their programs over a large period of time, say 6 months, and the coach was able to punch in some numbers of how fast it took them, you could ask very useful questions such as how much faster is their max speed increasing over time? How much is their 100-meter freestyle decreasing, and so forth. Another application for more casual swimmers is that you could create a smartwatch app where you could upload a program that either you've written yourself or someone else on the internet has written, and you could upload that to your watch and it would tell you and give you instructions while you're in the pool, while you're swimming. Smartwatches have heart rate monitors, and coaches can specify a heart rate goal for a particular instruction, and the watch could tell you whether you met that goal or not. The first step forward to creating such a standard, Christoph has created swiML, the swimming markup language. This is a technical and verbose language which does exactly what it set out to do of specifying swimming instructions, distances, repetitions, strokes, intensities, all of that information. But being an XML schema, it is very, very verbose, and a coach who has no technical background would struggle to author a program using this language. I needed to create an interface to swiML that is easy for coaches to write. To design this language, I set out to answer the question, how are people modeling swim programs digitally? So I read books, I read articles, blog posts, and I analyzed the syntax, not the content or the instructions of the programs, but I analyzed what is the symbols, what is the terminology that these people are using to convey important swimming concepts, such as the strokes, repetitions, intensity, and so forth. With this information, I created a language. swimDSL, DSL standing for domain-specific language, meaning a formal language which a computer can understand, but is specific to a certain domain, such as swimming instructions, is a language which models swimming instructions, but is readable and easy to write. So this here is an example of a swimming program which a coach may choose to write. And I hope that from reading the text you can understand what the swimmer should be doing. So, it is a formal language, and the coach will have to learn the language as most of you familiar with programming languages understand that a small syntax error means that the computer cannot make sense of the language. And so the coach who is non-technical has to learn what is correct and what is not. So to help them with learning the language, I've created a web editor application similar to a programming IDE. So we provide syntax highlighting to show the user that the particular words they are using are recognized by the language. I use linting, which is a way of highlighting errors and telling the coach, the author of the program, what they've done wrong and how they can fix it. And in many cases, we provide a button which can immediately fix their problems for them. We also provide auto-completions, so when they need to create a stroke, they press the first few characters and it suggests, oh, you probably want freestyle or maybe you want backstroke. Another important feature of this application is the live render. So as the coach or the user of this application is typing in their program, my application is reading it and translating it into the swiML language, which I showed earlier. It then translates the swiML into an HTML document, which it can render. So on the right-hand side, we have that rendered document, which is then easily exportable to a document which can be printed and brought along to the pool or can be shared with someone else on the internet. So to further help the coaches learn the language, I've provided comprehensive documentation with syntax examples and explanations of all the different features of the swimDSL language. Now, my goal in this project was to make this usable. The whole point of the translation from my language to swiML was to make it easy for coaches to author themselves. So in order to determine whether I had met this goal, I ran a user study. So the user study itself was 2 stages. The participants would transcribe a particular swimming program which I had written out in natural language, in plain English, and they had to transcribe it into the swimDSL language which I had created. Once they'd done that, they performed some basic operations in my web application, such as importing and exporting files to make sure that I had made the interface easy to use. Once they had done that, they filled out a survey. Now, this survey consisted of 2 parts. Some open-ended questions which aimed to gain some feedback to guide future development, and multi-choice Likert scale system usability scale questions. So this is a standard set of 10 questions. 5 of them are framed positively and 5 negatively, which aims to get a numerical score of the usability of a system, and it is quite common in software systems to use this system usability scale for evaluation of this. Right. So the results of my study of the system usability scale is sort of shown here as a distribution. So I had 8 participants. They were all either swimming coaches or competitive swimmers or squad swimmers who are familiar with having a coach write up instructions and familiar with having swum in a pool and know how this works. So in the literature, people have determined what scores for the system usability scale determine whether or not your application is usable. So it is determined that a score of 70 to 80 is determined good usability, and 80 or higher is determined excellent usability. So the goal of the project was to exceed a score of 70 points. So of the 8 respondents, 7 of them gave a total score of higher than 70, and the average score of all 8 participants was 72.5. Now, for some future development of this project, I would aim to increase the amount of different swimming concepts that the language could model. So some of the open-ended feedback from the swim coaches and participants that participated commented that there was particular aspects that they would have swum before, or in the coaches that they would give to their swimmers, that the language was not yet capable of modeling. So for future development, would be expanding the total set of swimming instructions that the project can model. And another piece of feedback that showed up from multiple of the participants was that the language was case sensitive and non-technical individuals couldn't care less whether the F in freestyle needed to be capital or not. So it's things like that where the language was enforcing them to do something which they saw no additional value from. And so changing that would improve the overall usability of the system. That's all from me. I'd like to again thank Christoph Bartnik for supervising my project, and thank you all for listening.
Thanks, Harrison. Plenty of time for questions. So any questions from the floor?
Henry.
Oh, what was some of the feedback you got from the people doing the study? What were they like wanting? Obviously, you pointed to the case-sensitive part.
Yeah, so actually a really good idea for future development to build on top of this language is to create a tool where the coach, so this was from a swim coach. I'm imagining a coaching platform where a coach comes along and they write up their programs using a language, so swimDSL language, but then they can come back after the swimmer has swum it, and the coach will have used a stopwatch or something to time them. And so they want the ability to incorporate the program data with timing data that how long it took the swimmer to swim each instruction. And that could even be automated if you had a fitness monitor or a smartwatch application that was scanning as you were swimming. And so the coach wanted to be able to combine the program data with the timing data so then they could then see over time, compare times to see how the swimmer is improving. And so to build on top of this, and that would be a really exciting application to make that coaching platform. Yes?
You think about fitting like a wrapper around the top of it to make the language a lot easier to use. So rather than people having to type the language in, they can simply select the amount of sets, select the distance, select the stroke, can't be that many, and then kind of have that then build the script for you.
Yeah, so there is definitely a possibility of something like that. As a software engineer, I think it would be similar to how block programming is good for someone learning to program for the first time. I imagine that a coach who would potentially use this every single day would probably end up prefer typing everything because it would ultimately be faster. But yes, as an introduction of the language, having a block programming style, GUI, would potentially be a good way of introducing new people to this, yes.
So I've got a couple of questions. So in this example, really the swimmer is like the computer,
yes.
and the coach is the programmer.
Yes.
And you're putting together something that's not too dissimilar from a similar language.
Sure.
So what are the nature of if we think about sort of programming, you've got if statements and while loops and for loops and so on. You've got these sorts of structures. How many sorts of different codes do you have?
So if I take a quick look at the example I've given here, up the top we have, it's a bit blurry on the screen. We have set statements, which are high-level declarations of things that are going to appear in the program render. So the very first line says set the title to example program, and you can see on the right-hand side example program. So that's a set statement. We have a pace definition statement, which there's a couple of those on the next few lines. A feature of the language that currently exists is that you can define a pace as a name. So instead of saying this should be performed at 70% of the swimmer's maximum speed, you can say perform it at an easy pace or perform this at race pace, and then you can just define what that percentage means. So we have repetition blocks, we have repeated instructions and blocked instructions to group things together. It is currently a fairly simplistic language in terms of there's not too many different kinds of statements.
This question kind of builds on the GUI question. Would you consider building some sort of large language model translation from natural text into the swiML language to help potentially people who I guess don't enjoy coding, even if it is like a simplified version?
That is quite an interesting question. I think that's actually quite an exciting possibility and application as well, because again, I'm imagining a coach who would probably, hopefully, get used to the language fairly quickly, but for someone who wants to try it out and would not use this every day, being able to sort of type it in natural language and have an LLM generate potentially not swimDSL, but the swimML underneath, then that would be an exciting way of another interface, user-friendly interface to the technical specification that is swimML. Yeah, that's cool.
Lovely. Well, we're out of time. Thank you very much.
Thank you.